All right, let's talk about one of the most incredible technological shifts that you probably never even thought about, the total reinvention of the aircraft cockpit. Seriously, this is a story that completely changed what it means to fly.
So how in the world did we get from this to this? From a wall of ticking mechanical gauges to these sleek digital dashboards that look like something out of a sci-fi movie. And look, this isn't just about making things look cooler. This is a deep dive into technology, human psychology, and the constant, relentless push to make flying safer for all of us.
You know, for decades, this was the pilot's office. A pilot had to be this master conductor, their eyes constantly scanning dozens and dozens of individual electromechanical instruments, what pilots affectionately call steam gauges, just to figure out what the plane was doing from one second to the next. And now this is what they see, the glass cockpit. That whole mechanical symphony, it's gone. It's been replaced by just a few really powerful screens. So why the huge change? What was the problem that was so big that it forced us to reinvent the pilot's entire world?
Well, it all comes down to the limits of the human brain. The old way of doing things, it was creating a really serious problem, something called cognitive overload.
I mean, just try to imagine it. You're trying to read and understand dozens of separate clocks all at the same time, all while you're flying this massive machine through the sky. Every single dial gave you one tiny piece of the puzzle, and it was the pilot's job inside their own head to put that puzzle together over and over and over again.
And here's where biology kicks in. The core of the issue is really just how we're built. It takes the average person about a quarter of a second just to see and start processing a single piece of visual information. Okay, now take that quarter second and multiply it by dozens of different dials. That time adds up incredibly fast. And during a really critical moment, like, say, landing in a bad storm, that mental delay, that strain, that could be the difference between a perfectly safe landing and a really serious mistake. Something had to change.
And that change wasn't just an update. It was a full-blown revolution. And it was all powered by the dawn of the digital age.
So this technology actually showed up first in military jets, way back in 1970 with the F-111D. Then in the 80s, it made the jump to commercial airliners like the MD-80 and Boeing 777 and 767. But the moment the game really, truly changed was in 1988 with the Airbus A20. That's widely seen as the first airliner with what we'd call a full glass cockpit.
The magic behind all of this is a technology called the Electronic Flight Instrument System, or EFIS. The easiest way to think about it is like it's the plane's new, smarter brain. Its whole job is to take all this data from dozens of different sensors, GPS, speed, gyros, you name it, and fuse it all together into one clear, integrated picture for the pilot.
And the advantages were, well, they were immediate. Right away, by putting everything in one spot, EFIS just slashed the amount of time a pilot had to spend scanning instruments. It could even show these incredible predictive cues, literally drawing on the screen where the plane was going to be in a few seconds. All of this meant less work for the pilot, fewer errors, and just a massive improvement in what we call situational awareness. It was a huge leap forward for safety.
But you know how it goes. Every revolution has its unintended consequences. In this new, super automated world, it created a totally different, much more subtle kind of challenge, all centered on that human element in the cockpit.
See, as pilots started spending more and more time with these new systems, researchers and even the pilots themselves, they started to notice a new kind of problem cropping up. The very tool that was designed to help them was actually changing the fundamental way that they fly.
And that created this fascinating new trade-off. The gains were obvious, right? Less work for the pilots, more efficient flights. But the risks, they were a lot more subtle. A pilot's basic manual flying skills, what they call their stick and rudder abilities, well, they could actually start to get rusty from not being used. And the complexity of the system could lead to something called mode confusion, which is a really dangerous state where the pilot thinks the autopilot is doing one thing, but it's actually doing something else entirely. A big study back in 2006 from Embry-Riddle Aeronautical University put it pretty bluntly. Their research suggested there was a direct link between pilots who relied heavily on automation and a decline in their fundamental flying skills. The very systems that were built for safety had created a brand new training challenge. And get this, that same study found a pretty startling number. Nearly 4 out of every 10 pilots with glass cockpit experience said they actually felt uncomfortable with the automation during the approach to landing, which is, of course, the most critical part of the whole flight. This just perfectly highlights that tension between the human pilot and the smart machine.
So, the story doesn't end there. Not at all.
The industry is now in this whole new phase, learning from the lessons of the glass cockpit to build an even safer, even smarter future.
And when you look at next-generation systems like Honeywell's Primus Epic 3.0, you can see they're designed to solve these exact problems. They're building in things like protection against GPS jamming, using synthetic vision so pilots can literally see through thick fog, and even adding cybersecurity to protect these increasingly connected aircraft.
And the next major leap? Well, it's already on the horizon, moving the information off the dashboard completely and projecting it directly into the pilot's line of sight using augmented reality and what are called head-up displays.
As Dr. Dennis Layer from Z's Micro-Optics puts it, the whole goal here is to let pilots see all that critical data without ever having to look down at their instruments. This keeps their eyes outside, scanning the sky where they should be. It might just be the ultimate fusion of the human and the machine.
Which leaves us with this one really critical question. As the cockpit keeps evolving, from dials to glass to augmented reality, what happens to the human in the seat? Are they still a pilot, or have they become more of a system manager? And that's the challenge that is going to define the next chapter of aviation.